Today's Lecture 8 of Basic Electronics is based on half-wave rectifier part 2.
Let's begin with today's lecture, that is the analysis of half-wave rectifier parameter. This is the part 2 of half-wave rectifier. Assume input is a sinusoidal signal. We all know that half-wave rectifier has a AC supply, that is, it is in sinusoidal. So the equation will be Vi, that is the input voltage, is equal to Vm. Vm here is the max peak voltage sine omega t. We all know that this is the equation. Okay. If we neglect diode drop, if there will be no diode drop, then output or load voltage will be VL is equal to Vm sine omega t. As we know that from this is our output, right? So this is a 0 to pi, and from here it is pi to 2 pi. So in the positive half cycle we will get the same input in this, that is the load voltage, but from pi to 2 pi, as it is in the negative half cycle, so we will get no voltage, that is there will be no current flow, so we will get load voltage as 0. Similarly, our load current will also have IL is equal to Im sin omega t, that is from 0 to pi, that is from in the positive half cycle we will get the same input which we are giving, that is Vm sin omega t. Instead of V we will write I because we are doing load current, but in the pi to 2 pi, which is a negative half cycle, we will get 0 as there will be no current flow. Now see, our Im, basically we know that V is equal to IR, so I will be always voltage by resistance, right? So here we are doing maximum voltage, that is the maximum peak voltage, which is Vm, by R2 plus Rf plus RL. This is the total resistance. In half-wave rectifier we have most of the books do not write this R2 because this is negligible, or they take it as 0. Okay. So R2 is basically transformer secondary resistance. This is mostly negligible. And RF is the forward diode resistance and RL is the load resistance. Okay. We now know all this. Now we have to know the parameters. So our first parameter is average or DC load current. Okay. IAV or IDC is equal to 1 by 2 pi. We can write it as we are finding out current, so we will write I as capital and AV as average, or DC we will write. So it will be 1 by 2 pi. Okay. 0 to 2 pi. IL we are finding current, so IL and d omega t. 0 to 2 pi having two parts, that is 0 to pi and pi to 2 pi. We know that this is 0 as there will be no current flow, so it will be 0. So we don't have to solve it. We just have to solve this one. So we will bring out the Im. So it will be Im by 2 pi, and we know that when we integrate sin omega t, it is minus cos omega t. We will put the limit 0 to pi. Whenever we put that the limit 0 to pi, it becomes minus I. We will bring this minus out. So minus Im by 2 pi, cos pi minus cos 0. We know that cos pi is minus 1 and cos 0 is 1, right? So see here, then it will be minus 2. So we cut the 2 and minus is plus. So we get my Im by pi. So our answer will be IAV or IDC is equal to Im by pi. The second parameter is RMS or AC load current. RMS is root mean square. We are finding current, so I will be in capital RMS. Root mean square. We are doing root, mean means average, and we are doing square. So 1 by 2 pi we will take from 0 to 2 pi. We know that pi to 2 pi is negative, so we will not write that here. That is the 0 part, that the current will not flow. We will take this one, and IL square is equal to, we know that the equation is Im sin omega t, right? IL is basically what? IL is basically Im sin omega t. Okay, so here it is I square m sin square omega t because we are doing square here. Next is we will solve this integration. We will bring out the I square m, right? We know that sin square omega t is 1 minus cos 2 omega t by 2. We will bring this 2 out, so it become I square m by 4 pi. Integration in respect to 1 will be omega t, and cos 2 omega t is minus is already there, so minus, and cos 2 omega t, we know that sin 2 omega t by 2, and we will put the limit 0 to pi. When we solve the limits, that is pi minus 0, when we write pi and then 0 and we keep pi and 0, we get as I square m by 4 pi into pi. Pi got cut, and when we take the root out, we get Im by 2. So IRMS is equal to Im by 2. This is the second parameter. Now we will head on to a third parameter, that is, it is the form factor. We know that it is defined as the ratio of RMS value to average value. So form factor is equal to RMS value by DC value. For half wave rectifier, form factor equal to, we know that RMS value is Im by 2. We found out this is the second parameter, and the first parameter was Im by pi. So we write that only Im by 2 by Im by pi. So Im by 2 into, we will take the pi up, and we will have the Im down. So Im and Im get cut, so we get pi by 2. So our form factor is equal to 1.57. Whenever we solve this by 2, we will get 1.57. Now we will know about the fourth parameter, that is the average or DC load voltage. We know that VAC is equal to IDC into R, that is voltage is equal to IR. So we have to find DC load voltage, so we write IDC into RL. IDC, we know that is our first parameter, that is Im by pi, and Im we find out as max voltage, that is a max peak voltage, and total resistance. So we write Vm into RL pi R2 plus RF plus RL. If RL is greater than R2 plus RF, then we will neglect the R2 plus RF, which will be negligible. So RL and RL get cut, so we get the answer as voltage VDC, that is the average or DC load voltage, is equal to Vm by pi. Now we'll be head on to our fifth parameter. Let's see. This is our fifth parameter, that is RMS load voltage. We know that voltage is equal to Im, so we have to find the RMS. So we are writing, we know that RMS is equal to Im by 2, and we know that Im is equal to total, that is max peak voltage, by total resistance, that is R2 plus RF plus RL, right? So Vm into RL by 2, R2 plus RF by plus RL. If RL is greater than R2 plus RF, then R2 plus RF will be negligible. So VRMS equal to Vm by 2 RL. So 2 RL get cut, and we get our answer as VL RMS, that is the RMS load voltage, is equal to Vm by 2. Now we will head on to our sixth parameter, that is ripple factor, which is one of the important. The rectifier output contains AC as well as DC component. We know that rectifier work is to convert DC current voltage to AC current voltage, that is alternating current voltage or current, into DC current or voltage. So rectifier will have the output of both AC and DC. The ripple factor basically measures the percentage of AC component present in the rectified output. If the ideal value of ripple factor should be 0, why 0? If we have the less ripple factor, then we will get the pure DC, right? So let's see how to solve ripple factor. Ripple factor we denote here as gamma. So RMS value of the AC component of output, because ripple factor take the percentage of AC component by DC value of OP. Here it's not IRMS, it is IACRMS by IDC. Okay, now we will see how we can solve it. See, the instantaneous AC value is given IAC equal to IL minus IDC. Basically it is nothing. We know that the total current is DC plus AC. and we always write DC with capital I and AC with small I. Okay, remember this. So we have to find IAC RMS. RMS means root, mean means average, and square. So we are finding IAC. So for IAC we will put IL minus IDC here, and we know that A minus B square is A square plus B square minus 2AB. Whenever we will now do integration, that is 1 by 2 pi, we will do one part by one part. Okay, so 1 by 2 pi integrate 0 to 2 pi I square L d omega t plus 1 by 2 pi 0 to 2 pi plus I square dc d omega t minus 2 IDC 2 pi. This 2 IDC we will take out by 2 pi, so 0 to 2 pi IL d omega t. This is basically our IDC which we have found, okay, which we have found in the first parameter, right? And this one is a RMS which we have found as a second parameter, so we will directly write as I square RMS plus I square DC by 2 pi. How? Whenever we integrate, we will take the I square out. So what will be the integration of omega t? That will 1 will be, that is omega t. So we will put the limits and we will get 2 pi minus 0. So 2 pi get cut, so we get I square dc and minus 2 I square dc, because this is the IDC which is the first parameter, and this IDC make it I square dc. So our last part 1, it will be minus, as it is minus 2 I square dc, we get the answer as I square RMS minus I square dc, right? Now see what will be the ripple factor then. Ripple factor omega is equal to IAC RMS by IDC equal to, we get this one, I square RMS minus I square DC. So if we take this IDC in the root, then it will be IRMS by IDC square, right? Minus 1. See, basically we take the whole like this, okay. We root here. So IDC by IDC square, which is 1. So we write that 1 here and this remains. So we know that RMS by DC is our form factor. So for half wave rectifier we know that it's 1.57. So when we solve it, we get our ripple factor as 1.21. So we come to the end of the half wave rectifier. Thank you.
Now it's the code time. If 4 things are followed, having a great aim, acquiring knowledge, hard work, and perseverance, then anything can be achieved. I think all of you understood today's lecture, and thank you for watching. Wow, that's impressive! You have completed a magic today. For more videos, subscribe! Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.